Hello and welcome to the British Antarctic Survey's live stream. We are going to start in just a second and I'm going to be talking about Antarctica, the mysteries of the ice. So hello, I'm Ella. I'm a climate scientist at the British Antarctic Survey. I know you can't see me right now, but if you could, I would be doing this. So hopefully you can also see a Q&A box underneath this video. So please feel free to ask any questions that you come up with throughout this talk. Just type them into the box as you think of them, and I'll try and answer them to the best of my ability at the end. So hopefully, because you're here, you don't need convincing that Antarctica is amazing. Not only is it one of the only places you can find penguins, and by the way, you should enjoy this picture of a penguin because it is the only one you will find in this whole talk. Not only has it got penguins, but it is also extraordinarily picturesque, and it is the highest, driest, windiest, remotest continent. So it really is a place of absolute extremes. Now, Antarctica is really incredible, but it's also experiencing lots of impacts to do with climate change. So the subject of today's talk is going to be, how is climate change affecting Antarctic ice, and specifically one type of Antarctic ice? So before we dive straight into this question, I think we should do a little bit of background. So not all Antarctic ice is created equal. In fact, there are three main types of ice in Antarctica. So first up, we've got the ice sheet, then we've got ice shelves, and then finally, we've also got sea ice. So for those who aren't familiar, ice sheets are what we typically think of when we think of the ice caps. In Antarctica, ice sits on top of a very rocky continent underneath, and in places it is up to 4 kilometers thick. On average is about 2.7 kilometers thick. Now ice flows off these ice sheets in frozen kind of rivers or ice streams that are called glaciers. And when those glaciers meet the ocean, they spread out into tongues or floating platforms of ice that we call ice shelves. Now, the arrow on this diagram shows you where the grounding line is, and the grounding line is where the ice sheet essentially becomes ice shelf. So where the ice shelf starts floating and it's pinned to the seabed beneath. Should also add that ice shelves often have icebergs breaking away from them, and that's part of the natural growth cycle of ice shelves. So you have glaciers feeding ice into the ice shelf, and then periodically they will have icebergs breaking away, and that's part of their natural cycles of staying in balance. So finally, we've got sea ice, and sea ice forms on top of the ocean when the sea is at near freezing temperatures, and it floats just on top. And it's seasonal, so it means that in winter we have lots more sea ice around the continent, and in summer we have relatively less. So you can actually see in satellite images, for instance, that the continent size grows and shrinks depending on what time of year it is. So all of these different types of ice have different properties. So if we take sea ice, for instance, it's typically less than 5 meters thick. It's also very young, so it's less than 5 years old. And if on the flip side, we've got ice sheets, and an ice sheet can be, as I said, up to 4 kilometers thick and can be millions of years old. Polar opposites, you could say, in fact. Now, we're going to be focusing today on ice shelves, which are somewhere in the middle. So they are hundreds to thousands of meters thick, and they can be tens of thousands, occasionally hundreds of thousands of years old. So this is my first question to you. Why is an ice shelf like a sandwich? I'm willing to bet you probably haven't asked yourself this before, but I have. And the answer is that ice shelves are getting melted from above and below by rising temperatures. So we've got warming atmosphere, a warming ocean, and those ice shelves are sandwiched between in a melt sandwich. Warming oceans, of course, thin ice shelves from the bottom, and warmer atmosphere thins it from the top. Now we can measure climate change over ice shelves in Antarctica in all sorts of different ways. So this video shows some scientists doing some drilling, which helps them understand the structure of ice shelves and what might be changing or staying the same. Then we've also got other techniques such as geophysical surveys, where scientists go and trigger off lots of mini explosions and measure how the shockwaves travel through the ice shelf. You can also do underwater research with unmanned vehicles, like in this other picture, bright orange missile looking thing. I've often done work using very big computer models to understand what's happening in the atmosphere above ice shelves, but you can also use other observational techniques to measure the atmosphere. So I thought I would share with you some of the ones that I've got a bit of experience with. I went to Antarctica and did some releasing of radiosondes, which are also known as weather balloons. And these are a really important and useful tool that we can use to monitor the weather and climate over a long time period. So as you'll see in the following video, what's going to happen is I'm going to be releasing a weather balloon, and at the bottom we've got a package of scientific instruments which measure temperature, pressure, humidity, winds, this kind of thing. And when you let go of the balloon, it goes up, up, up through the atmosphere, and it records all of those properties of the atmosphere as it goes, and that gives us a really fantastic picture of what's happening at any one time. So hopefully this will work. Welcome to our very glamorous Met office here at Rotherham. Just come from the Met brief. So the first thing to do after the first air of the day is to release the sonde. So radiosondes, or weather balloons, are just one way that we can do long-term monitoring of Antarctic climate change in the atmosphere. But I was also lucky enough to be involved in a campaign using aircraft. So aircraft observations are really helpful to get an in-depth understanding of the processes that are going on over ice shelves and how the climate and the atmosphere is changing. So I thought I would give you a very brief picture of what it's like to go on a research aircraft field campaign in the Antarctic. So I'm going to play you another video which should give you an idea of what it's like. So hopefully you spotted that we were flying over an ice shelf and alongside an ice shelf and trying to understand all sorts of different things about the atmosphere around that ice shelf. And this is because ice shelves can change really, really rapidly. So understanding what's going on above them is actually really important. So on this left-hand picture is a series of images from a satellite of an ice shelf called Larsen B, which is on the Antarctic Peninsula, which is in that red circle you can see in the top right. And over the course of about a month or 5 weeks in 2002, that ice shelf collapsed, and it took scientists almost by surprise because it happened so quickly. And long-term monitoring and campaigns like that are really important. And in fact, when I took that footage a few months before, the ice shelf that we had been flying over, which is called Larsen C, which is right next door to Larsen B, a gigantic iceberg had just broken off of it, and it was a quarter of the size of Wales, and we were flying along the side of it. And because we'd been doing so much monitoring and scientific research down there, we knew that that was going to happen, whereas in 2002, the collapse of that ice shelf was quite dramatic. Now, we care about this because of sea level rise. Not just because of sea level rise, but this is a very important factor. So on the left-hand side here, we've got a picture of what the European coastlines would look like if all the ice in Antarctica were going to melt. And now this isn't going to happen tomorrow by any means, but you can just see what a dramatic change it would have. For instance, the whole of Norfolk and Cambridgeshire, probably London, are all underwater, entire countries such as the Netherlands, and this is a really dramatic rewriting of the world map. Now, I said that that isn't going to happen tomorrow, but more importantly, in the next century or so, if we do not do anything to mitigate our emissions and curb the rate of climate change, the IPCC, so the Intergovernmental Panel on Climate Change, which is a global consensus of what climate scientists think worldwide, they project that global average sea level might rise by around 1 meter by the end of the century. And to put that into context, we've so far since 1900 seen around 15 centimeters. So that is a really large, big difference. It's 5 times that. I've been talking about sea level rise, but ice shelves actually don't necessarily contribute to sea level rise directly. Just like if I had a glass of water with some ice cubes in it, if those ice cubes started melting, my glass of water wouldn't overflow. And it's the same deal with ice shelves because they're already floating. So they already displace their own weight in water. What it means is that ice shelves and Antarctic ice shelves don't directly contribute to sea level rise. But the reason we care about ice shelves collapsing in the context of sea level rise is because they act as a plug. So if you remember in the beginning, I said that ice shelves are formed by glaciers that flow off the ice sheet. If you remove the ice shelf, it's like pulling the plug in the sink, and those glaciers can flow straight off the ice sheet, off the high terrain of the Antarctic continent, and flow unrestrained into the ocean. And that is what causes the sea level rise. That is what we care about. Now, the causes of climate change and melting ice shelves are different depending on where in Antarctica we're considering. So, for example, in the West Antarctic, where lots of the ice shelves and glaciers sit on top of seabed that slopes backwards, we see a much bigger influence of the ocean warming underneath those glaciers. So this is an example from Thwaites. The British Antarctic Survey is involved in a really big international collaborative effort to understand what's going on lots of the ice shelves around West Antarctica, but particularly the focus at the moment is on this glacier called the Thwaites Glacier. So as I mentioned, lots of these ice shelves and glaciers are located on parts of the seabed that start sloping backwards. So if you remember that grounding line, that pinning point between the ice shelf and the sea and the bedrock underneath where the ice shelf starts floating, when it's on a relatively flat part of the bedrock, it is quite stable. What happens is when you get oceanic warming, the grounding line starts to recede and more water can enter the gap underneath the ice shelf, because you get a bigger gap and a bigger cavity below the ice shelf, and then you get more and more warm water getting underneath and melting it from the bottom up. Then of course you get chunks of ice breaking away and the ice shelf starts to recede and the glacier gets much faster, so the essentially a frozen river starts speeding up and more ice ends up in the ocean. By contrast, if we think about the Antarctic Peninsula, which is this little bit that sticks out just in that red circle again, there's much stronger influence of the atmosphere here. So the Antarctic Peninsula is characterized by its geography as well. So it's got a very long, thin chain of mountains that goes all the way up the spine of the peninsula. And this means that we get a very specific phenomenon. And these are called föhn winds. And if you, like me, don't speak German and haven't been skiing in the Alps, then you might not know that föhn means hairdryer in German. I'm reliably informed of this. I don't actually know if my pronunciation is right. But what happens is that when air is forced to flow over mountains, when it descends on the other side, it gets warmer and drier. And that can raise temperatures over ice shelves on the other side enough to cause surface melting. So you get lots and lots of melting on the surface of ice shelves on the other side of the mountains. Now, if you'll permit me a small deviation to explain why this is important. So if we think about the way that an ice shelf is structured, at the very bottom, we've got solid ice, and at the very top, we've got the freshest, newest layer of snow. So I'm going to introduce a related concept that's also confusingly called föhn, but with an R. So föhn is this kind of transitional product. It's not quite snow and it's not quite ice either. So if you think about how an ice shelf is formed, year after year, more and more snow falls on top of older layers, and every single year you get a new layer. And each layer will get more and more squished down until eventually, when it's right at the bottom of the ice shelf, it's basically just ice. It's completely dense and compacted. The föhn, with an R, is the bit in the middle. So it's not quite snow and it's not quite ice. But importantly, it's got lots of air bubbles, because when that snow falls, it traps little pockets of air between each of the flakes. What that means is, and why it's important, is because those air bubbles have spaces in which you can absorb and collect meltwater. So if you get lots of surface melting on the top of the ice shelf, it can trickle down into that föhn layer and it can refreeze the following winter. And that's okay, because if you have the same amount of föhn being refrozen and then being created by more and more snow, then that's an ice shelf imbalance. What happens sometimes when you get too much surface melting and more surface melting than can be balanced by the refreezing and new snow input, then you get that föhn layer being completely saturated, and eventually it will get so dense that it's essentially an entire lump of ice. If that happens, that's a bit of a problem, because if you get surface melting the following year, that meltwater has nowhere to go, and it collects in big lakes and ponds on the surface of the ice shelf. And rather than trickling into the föhn layer and being refrozen, it will trickle into existing cracks and rifts and crevasses, and it will fill those up. And once it gets past a certain threshold, so here, the magic 90%, then the weight of that water is so vast that it causes the crack to widen and to deepen, so much so that sometimes those cracks can propagate right down to the bottom of the ice shelf, and it can cause them to splinter. And this process is called hydrofracturing, so literally cracking by water. And it can explain the very dramatic events that we see in ice shelves, such as the Larsen B scenario I showed you earlier. You can see the melt ponds start collecting in the early pictures, and then by the end, that hydrofracturing process has really taken hold, and lots of icebergs have been produced, and the ice shelf has collapsed. So BAS science has helped us understand these sorts of processes, and it's been really important to understand how ice shelves are changing and how the atmosphere and oceans are changing in the Antarctic. And it's really important to be able to look after this incredible environment and protect it so that everyone gets to enjoy it for future generations. So that's it from me. If you would like to learn more about anything I've been talking about, then the British Antarctic Survey website has loads of great resources, so you can check those out. I also really recommend this website, antarcticglaciers.co.uk, run by a colleague in Wales. And I also produce short explainer videos on YouTube, and you can follow me on Twitter, and I'm Dr Gilbert with a Z for both of those. So hopefully you've got loads and loads of questions, and I'm going to do my absolute best to answer them. So I'm going to hopefully switch to my face. And hopefully you can see. Great. Lovely. Okay, so we've got lots of questions. How about this one? So first up, I'm not sure if you can see this, but how does the ice shelf stay afloat? And the answer is, just like an ice cube stays afloat in your drink, it's a different, the different buoyancy. So it's actually lighter. Is Antarctica a fun place? It's unbelievable. It's a really incredible environment, and it's a pleasure and a privilege to be able to go and do scientific research there. And I'm extraordinarily grateful for having been able to do that. Okay, I've got one. How did you become a scientist in Antarctica? In a very roundabout way. I was always really keen on geography and environmental science, and I've always had a passion for the outdoors, and Antarctica has always fascinated me. It's really captivating, incredible environment that I think we should be protecting for generations to come, and have always been really keen on it. So I eventually ended up doing my PhD at the British Antarctic Survey, and I've never looked back since. Ooh, thick and fast, these questions. Okay. Will any islands disappear below the sea if the ice sheets melt? The answer to that is yes, depending on how much melting happens. Sea level rise is already impacting lots of small island developing states, particularly in the South Pacific, islands like Tuvalu, for example, where people are already feeling the impacts of climate change, and it's really affecting their livelihoods and their ways of life. So the more we can do to limit climate change, the better. Was Antarctica ever free of ice? Yes, over the entirety of Earth history, there have been periods when Antarctica was completely covered in dense jungle. There have been periods when it was completely, even more icy than it is today. So it's a really incredible place. But of course, over the course of millions and billions of years, it has changed very, very significantly. What will happen to the sea creatures if the ice shelves melt? Good question. Changing Antarctic oceans and oceans generally will impact different parts of the ecosystem, different creatures, different animals and plants in different ways. Some of them may find that it's better for them, but mostly it will be not so good, and they're going to have to find new ways to adapt to a warmer environment, and it will probably affect populations of animals in quite negative ways. One question from David: is it always cold? Depends on your definition of cold, I suppose. It's a huge continent with a very vast range of temperatures. So if you go to South Pole or the high plateau of Antarctica, for example, the temperatures are a lot colder, particularly in winter, down to minus 89, minus 90. But then if you think about the Antarctic Peninsula or the subantarctic islands, then you can get temperatures that are easily above zero in the summer. So it's a really wide range. Are there polar bears and emperor penguins in Antarctica? There are penguins, yes, but polar bears, no. So they live at opposite ends of the earth and have never met. And let's hope it stays that way, because I feel like the penguins would be worse off. What does my job as a climate scientist actually entail? Oh, great question. It's very varied. Yes, climate scientist is quite a vague term. I'm a climate modeler, so I use computer models to understand processes that are happening in Antarctica. So I use the Met Office weather forecasting model that we use to predict the UK's weather, but I use it in Antarctica. And I also use it to forecast things at times that have already happened. So you might say that's not that useful necessarily, but it's really important to understand the processes that are going on because we don't have that much information. And I compare it with all sorts of observations. So like those weather balloons that I showed you a video of, or the aircraft campaigns, I use that sort of information to cross-reference and see how things are changing, what is going on there. Oh, I've been corrected on my German fern spelling. Excellent. Thank you very much, Anonymous. Have I seen any cute penguins? I must say I've only seen Adelies because I've only been to Rothera, which is on the peninsula, and there aren't any chin straps, as you've asked, unfortunately, but maybe next time. Other questions. To what extent does the cruise industry affect the environment in Antarctica, and how can this impact be reduced? Oh, that's an interesting question. I would say that in some ways it's good to have some element of tourism in Antarctica because it encourages people to think about how amazing it is and to protect it. But it also means that you have more people going near the Antarctic, which is obviously a problem, and we want to protect it and keep it pristine. So we have an Antarctic treaty which protects the continent and makes sure that it is for peaceful scientific purposes, and that we use it for research and to improve our understanding of the world, and we keep it as untouched as possible. Some other questions. Have I ever seen a baby penguin? I haven't. I was wondering how many penguin questions I would get. Do many scientists working at BAS get the chance to go to Antarctica, and how often? Yes, lots of scientists working at BAS go to Antarctica. I feel very lucky to be counted among them. Some people go every season. Some people stay down there working for longer periods of time, and others do research that is that they can do from the UK. So it's not so important for them to go every single year there. So it really varies. Depends what you're doing. If no one cares about the environment, what will happen? That's a good question. I would say that if no one cares about it, then we will lose it. And that would be absolutely tragic, not only because it's our planetary heritage, if you like, but it's also a really important part of the climate system. So if we lose the polar regions, then not only will we see a lot of sea level rise, but we'll also have a very different planet to the one that we currently live on. So because the Arctic and the Antarctic are so bright white, they reflect all sorts of incoming solar radiation, and that changes the energy balance of the planet, and that means that it would change our climate worldwide. Common types of fish that live in those cold waters. You know what? I'm not a biologist and I don't actually know. Embarrassing. How many animal species are in Antarctica? Again, not sure. If you want to ask me questions about climate, I'm all over it. Have I ever seen an ice shelf collapse? No, but luckily we were the first research aircraft team to go down following the breakaway of that gigantic iceberg from the ice shelf Larsen C in 2017. So I haven't seen it collapse directly, and it's actually pretty much impossible to witness that unless you have lots of satellite imagery or you're very much in the right place at the right time. But we did see the recent aftermath of an iceberg breaking away, which I thought was very cool. Got some of the first ever footage. In fact, you saw some of the first ever footage. Is the 1 meter increase in global sea level in the next 100 years considering feedback mechanisms? Great question. So I assume that's referring to the IPCC projection of end of century projections for sea level, but in assuming our current emissions trajectory. I think it does include these. There's been several papers recently that have suggested that sea level rise may actually be greater than 1 meter if we keep emitting as we are, business as usual. But of course, those feedback mechanisms start kicking in over longer timeframes as well. So that doesn't necessarily stop sea level rise at 1 century. It will keep going into the 2200s and the 2300s. Questions about fossils. Do you find any fossils in the ice? And if so, what are the most common type? And are there many fossils in Antarctica? Not being a geologist, I'm going to answer this poorly, I'm sure. But you can find fossils in Antarctica. And this is how we know that Antarctica has gone through various different stages in its evolution. So at some point, I mentioned earlier that it's been completely covered in forest, which is incredible if you think about it now. And that's information that we've gained from fossils and fossil evidence and geological evidence. There are some parts of Antarctica where fossils are much easier to find. Of course, being covered in ice is quite difficult to retrieve them, but some parts of Antarctica are actually not covered in ice. For example, in the McMurdo dry valleys, where you've got lots of bare rock exposed, and you can very easily find incredible geological specimens there. I think I've definitely seen some good ones. Couldn't tell you where they were from exactly. Are there many unexplored cave networks down there? And if so, could there be living ecosystems? Very interesting point. I don't know the answer to that. There could be. I'm afraid you'll have to ask someone who's more of a specialist in this. Hi, are there any other ice shelves you would like to study? Oh yeah, the list is endless. I adore understanding the Antarctic environment, and if I can apply my knowledge and experience to any others, then I would absolutely love to do that. How is frost shattering, i.e. freeze-thaw action, different from hydrofracturing? It's a good question, actually. I suppose it's a very similar process. But I think the difference is because rather than the water filling a crevasse and then freezing and causing something to splinter or shatter, I think it's the actual weight of the liquid water. So it's not necessarily that it percolates into a crack and then freezes, expands, and shatters something. It's more that it trickles into a crevasse and the weight of that water is so great that it causes cracks to propagate. Is it possible to reverse the impact of melting ice in Antarctica? Over very long timescales, yes. And the Earth has been much hotter than it is today in Earth history, and similarly, it's been much colder than it is today. Within human timescales, most of what we're going to be able to do is to limit further ice loss and further change. Of course, the climate varies quite a lot, so it's naturally some periods might be colder or warmer, and it's not a very clear single signal, but it is important to note that climate change is obviously affecting Antarctica negatively, and that everything that we do to mitigate our impact by reducing our emissions and protecting the environment is going to be good. See if we've got any other questions. What do I think about the argument that we're entering an anti-glacial time period? I presume you mean interglacial, and that melting is inevitable. Well, on one hand, I do think melting is inevitable because we're locked into contemporary climate change of at least 1.5 degrees so far, probably. And I think it depends very much on the timescale you're considering. On human timescales, centuries or so, then anthropogenic or human-caused climate change is a huge problem, and it is something that we will have to face as a species. Of course, the climate will change on a much larger timescale, as it has done for millennia, but I don't think it's necessarily relevant to focus on glacial time scales. I think if I haven't answered your question, I'm really sorry. I'm trying to find if there are any that I haven't done yet. But if there are no more questions, then thank you so much. Oh, hang on. How do I go about modeling the climate? New one. What software and data do I use? So I use a giant supercomputer called, well, a few different ones, but they're absolutely vast. The one that I use is in the UK Met Office. I use the UK Met Office's forecast model, weather and forecast model. So that's one part of the software that I use. And then I also write lots of scripts in Python to understand all the data that gets spat out. Have I been to the Arctic? I have. I can't say I did spend very much time there. It was around 2 weeks. Very lucky again. Have we seen a change in the Antarctic as a result of COVID-19 pandemic? Given that I'm currently in the UK, I couldn't comment on that one particularly. It's definitely made logistics and science a little bit more challenging. And the focus is obviously making sure that Antarctica stays COVID-free and that staff are able to return home safely and without getting COVID, of course. How did I find being isolated from normal society in Antarctica? it's like being in a small village. I mean, there's lots of lovely people around and all sorts of things to entertain yourself when you're on station. And of course, you're really focused on your research and getting everything done. So it's actually not that different to normal life. Of course, you just can't go to the pub or go to outside to a park or whatever it is that you want to do. It's just a little bit different. It takes a bit of adapting. How do you... Oh, sorry, it's missed. Are there any plants in Antarctica? Interesting question. There aren't any, but there are some in the subantarctic, mosses and lichens mostly, I think. Is Antarctica volcanic? There are some volcanoes in Antarctica. Mount Erebus, for example. How do you know whether the ground slopes up or down? Presumably that's about the seabed underneath ice shelves. So we can do radar surveys. So you can either fly an aircraft over it, or you can use other types of radar from the surface to send signals down through the ice, and then you can measure what comes back. And from that, we can infer how thick the ice is and what the ground underneath looks like. What happens to the weather balloon? Excellent question. It falls once it explodes, and if you can retrieve it, then we try to do that. That's not always possible. So that is, of course, a problem. Did I study a master's before I did my PhD? I did. I did a climate change master's at the University of East Anglia. It was an excellent setup. How many ice shelves are there? Oh, great question. I don't actually know. Many. There are, I think, 12 on the peninsula at least, and then so many others around the whole continent. I couldn't tell you exact number. How cold is Antarctica? The Antarctic continent, coldest temperature ever recorded was -89, and I think satellites think that maybe it might go down to about -94 in some parts of the continent where we've got no people to take observations. So that's really, really cold, obviously in the depths of winter when there's no sun, hasn't been any sun for months and months, and it's exceptionally cold. And of course, it can get above 0 in the summer in the parts of Antarctica that are further away from the South Pole. Last few questions. Have I seen the Southern Lights? I wish. I was only there during the summer, and it's impossible to see the Southern Lights in summer because you've got 24-hour daylight. That's something that I would absolutely love to tick off my bucket list. What's been my longest stay in Antarctica? Only one so far, and it was 6 or 7 weeks over Christmas. It was an extraordinarily memorable time, I have to say. I don't think I'll ever have 53 people at Christmas dinner ever again. My family is certainly not that big. What happens when the weather balloons run out of helium? They actually get to a level in the atmosphere where the pressure is so low that the balloon is really gigantic, and by that point it explodes and the instruments all fall to Earth. Do I have any Antarctic themed tattoos? No, maybe I should get some. Do warming temperatures melt the ice faster? Yes. So if we've got rising surface air temperatures, then of course you've got more energy in the atmosphere, or this also applies to the ocean. So you've got more energy that can do lots of melting. And if you've got air that's 1 degree, it's going to melt less, than air that's 10 degrees. What do I think will happen in Antarctica in 2030? 2030 is alarmingly not that far away now. So I think it will look quite a lot like it does today. I think perhaps a few more of the glaciers in West Antarctica might start to speed up even more. We're already kind of locked into a certain amount of climate change and warming, but of course it's really impossible to predict these sorts of things, and it also depends a little bit on our actions as humans, how much we reduce our emissions, how much we limit the effects of climate change. After ice shelf collapse, can geographic features like mountains plug glaciers from reaching the sea, like a new grounding line? Great question. I think, generally speaking, glaciers are sort of where they are is due to the geography underneath. So you get basins and ice shelves will form around bits that kind of pin them in and so forth. So if you lose them, I guess eventually you'd get new ice shelves. Good question. I haven't thought about that one before. Are there walls in Antarctica? There are not. And what is mainly melting the ice? Like I said in the talk, it depends a little bit on where you are. So whether that's melting due to warming oceans or melting due to foehn winds or atmospheric warming because of climate change. It really depends on the season. It's basically a very complicated picture. But in summary, I suppose we can say climate change is having quite a large and noticeable impact. What would I like to do after finishing my PhD at Bath? Oh, I don't know. If anyone wants to help me out with that one, then be my guest. Do lots of science communication, I think, because I feel like climate change affects everybody and everybody should be able to understand the science of it because it's the planet belongs to all of us. Should children be taught climate change in school? Absolutely, yes. I gave a talk at a school for Key Stage 2 students a few months ago, and I think a 7-year-old gave me the most textbook definition of climate change I've ever heard, and I thought, well, I can go home now then. So I think they already do teach climate change in some schools, and I absolutely agree that it should be on the curriculum and we should all be taught to care about it. Can research be done remotely by robots, etc.? Yeah, so lots and lots of research is happening now with unmanned vehicles, so underwater gliders and these new technological inventions that profile the ocean, for example. We also have automatic weather stations which monitor the weather and climate long term over areas that we can't actually access. So you go once a year to service those stations, and then you collect the data and it will transmit it back to us wherever we are in the world. So we can automate lots of it, and that's a really important part of the work, and will become even more important, I'd say, as we need to start thinking about ways of doing it with less human impact, so both to reduce our emissions and also to make it more streamlined. Is there internet? In Antarctica, presumably. There is, but it's very limited in some ways because it's a satellite internet connection. So it's prioritized for the most important things like scientific research and communications for safety. Okay, I think that might be the last few questions. So please feel free to email me or get in touch on Twitter if there's anything that you think I didn't answer, or if you're interested in connecting anyway. Yeah, if there's nothing else, then thank you so much for listening and watching this talk. And I hope that you'll engage in some more climate science stuff soon. Thank you very much.